All right, guys, you're probably getting on to problem number 20 on your homework, and you might have set up the equations, but you're not really sure what to do after that. So your equations may look similar to the ones I have here with different coefficients, and they should both be equal to 90. What I'm going to do is solve by elimination. Now, there are lots of ways to solve an equation like this, and substitution is another valid way to do it. I don't like substitution. I will show you that on the next slide. However, I'm going to start with elimination because that's my preferred method. So we're going to multiply everything in the bottom equation. I'm going to make the y's match because 5 seems like a little bit easier to deal with than 6. So I'm going to multiply everything through by 5. So this guy up here, he changes nothing at all. 6x plus 5y equals 12. That is an identical equation. This one down here on the bottom changes by 5, by a multiple of 5. So this is 5x plus 5y is equal to 10. Now you'll notice I've got two variables that are matching. So I've got a 5y here and a 5y here. Now, you may have been taught to multiply through by a negative so that it changes the signs, and then you can always add. I don't like that method. I would prefer to find a way to eliminate the variables. So what do I need to do to these two equations so that these 5y's go away? How do I get rid of the 5y's? Well, I get rid of the 5y's by subtracting. 5y minus 5y is 0. So that's what I'm going to do here. I'm going to subtract everything in the second equation from everything in the first equation. So I get 6x minus 5x, and that gives me just a plain old x, or a 1x. 5y minus 5y cancels out. 12 minus 10 gives me 2. That tells me that x equals 2. But I'm not done. I actually have to go back in and substitute in this x equals 2 into either of these two equations for where the x is. Now, one is easier than the other, so I'm going to choose the second equation. So to substitute back in, I would get, instead of x, I'm going to write what x equals. So I'm going to write 2 plus y is equal to 2. Now I subtract 2 from both sides, and y is equal to 0. So that means that my x value is 2 and my y value is 0. All right, so maybe you prefer to substitute. If you'd like to substitute, I would suggest solving for x. Either one works. It really won't make any difference in the long run. Just a preference, and it just looks easier to me to solve for x. So I would subtract y from both sides, and then these guys would cancel out, and so x would equal 2 minus y. So now I have to substitute, and that means that I have to take this 2 minus y and plug it in where I see an x. So I'm going to do that off to the side over here. So I'm going to do 6, and then instead of x, I'm going to write what x is equal to, which is 2 minus y, plus 5y equals 12. Now I've got to do some algebra, and this is why I don't prefer the substitution method, because this is where I make mistakes. So I'm going to distribute, and I only distribute to what's in the parentheses, so I get 12 minus 6y plus 5y is equal to 12. Okay, so that was 6 times 2 is 12, 6 times y is 6y, and then I just brought down my plus 5y. Now I'm going to combine like terms, so my like terms are the negative 6y and the positive 5y, so that's 12 minus y is equal to 12. Then I'm going to subtract 12 from both sides. That gives me a negative y is equal to 0, or y is equal to 0. Now, the one nice thing about doing it this way is that I don't have to, when I substitute in, it's a lot easier. So I'm going to take this y equals 0, and I'm going to plug it right back here. So that gives me that x is equal to 2 minus 0, or x is equal to 2. So my ordered pair is 2, 0, just like it was in the first time.